Hi, and welcome to Geeks for Geeks. I'm Siddharth, and today we would be discussing yesterday's problem of the day, that is equal left and right subarray sum. So, as the name suggests, this problem statement is a little bit easy to process, and this problem was on the very easy part. So, now let me just quickly share my screen. Let me take a snap. Yep. So now in this problem, we are given an array and the task is to find the first index such that the elements before it is equal to the sum of elements after it. So suppose first we would be going to this. So elements before it is 0 and the elements after it is 2 plus 2 4, 9 and then 12. Okay. Now let's say that we are considering this. So sum of the elements before it is 1 and the sum of the elements after it is 9. So this is also not equal. Now we have this. Sum of the elements after it is 4 and the sum of the elements before it is 4. That is why the third index is returned at this point. So we need to insert, like we need to answer the first index or the sum of the elements is before and after it. Okay. So let us do what is said in this problem. Let us try the brute force approach. So what we can do is, suppose we are given A1, A2, A3, A4 and A5. Let's say we have A0 also. Okay. Suppose we are at AI. So to get the sum of the left hand side, we would iterate from I0 till the value of I minus 1. And to get the sum of the right hand side, we would go from I plus 1 till the value of n itself. Okay, seems easy. Now, the time complexity of this approach would be that here we are considering the sum, like altogether, we are having the sum of n minus 1 element. Ignoring the constant, at each index, we are doing n operation. So for one index, we are doing an operation. And in the worst scenario, the index might be the last index. So for n index, multiplying n on both sides, we are having n square operation. Okay. So now 10 to the power 6 multiplied by 10 to the power 6 is 10 to the power 12. That is greater than 10 to the power 8 operation. So the verdict would be definitely a time limit exceeded. Now, we need to think of something better. So now, whenever we hear the thing known as array and we hear the thing known as sum, the first thing that should pop in our mind is prefix sum itself. Okay, this should be the first thing that should hit in your mind. So now what we can do is, by using prefix sum, we can have the sum of the previous part and we can have the sum of the after part. Okay. Now, how a prefix sum is generated, let me just show you. Suppose we have 1, 3, 5, 2, 2. So suppose we have 1, 3, 5, 2, and 2. So prefix sum is nothing but sum till this point. So starting from the first point to this point, the sum is 1 and the sum till this point is 1 plus 3. So previous prefix value and the current value would tell me 4. Now 4 plus 5 that is equal to 9, and 9 plus 2 that is equal to 11. 11 plus 2 is equals to the value 13 itself. So we can see that we can build out the prefix sum. See, first element has no previous element. So we can explicitly define that P prefix sum of 0 is equals to A of 0. And rest all the values is the current sum plus the prefix sum's previous sum. So rest all the values of P of I is equals to P of I minus 1, okay, and A of I. And suppose we want the sum from this to this. So it would be the value of this one. Suppose we want the sum of 5 and 2. So first we would take the sum till this point, which is equals to 11. And then we would remove the sum of this, that is 4, which would give me the value 7. So how are we doing this? We are doing this by saying that if we want the sum of L to R, we would say P of R minus P of L minus 1. Why do we do that? Suppose we want the sum of 3 and 5. So we would take the sum till this point. Then we would remove, this is L, so this we would remove this part. Okay, this is how we would do it. Okay, so now let us use the prefix sum. Yep. Okay, so I'm a lazy person, won't be writing, won't be hitting. So yeah. So now first we would define P of n, and then we would say P of 0 is equals to A of 0 itself. And then we would start from the very first index because 0th index is already defined. So for int I is equals to 1, I is less than n, and I plus plus, and P of I is equals to P of I minus 1 plus the current value. This is how we are building up the prefix sum. Okay. Now, after this point, so let me just have a vector because sometimes arrays more than 10 to the power 5 behaves differently. Okay, so let me just have this. Yep, this is done. So now we have the prefix sum. So now we would start iterating from point 0 till the point n. So now we would say for int I is equals to 0, I is less than n, and I plus plus. And we would define a function explicitly. Okay. Here what we would do is we would say this should return me a sum. Okay, this should be a long. Okay, and this should also become long. So long sum of L to R. And here I would accept a parameter known as vector int long passed by reference, and then I would have L and R. Okay, so I would say the sum is equals to P of R. Okay, so see, we are having the sum of P of R. But if L minus 1 is negative, suppose I want the sum of this part, then L minus 1 doesn't have an index. So we need a if statement to handle this. So now we would be saying if L is greater than 0, then only sum minus is equal to P of L minus 1. Okay, and then we would return the sum. Okay, fair enough. And we can also say that the R can be also at the negative value. Like we can say that what if the range of L and R both lies here? So we would also have a condition for this. So we would have for int long sum is equals to 0. Okay, and here we would say if the current index, if r is greater than equal to the value 0, then only sum is equal to p of r. Like if it is within the index. If it is less than 0 means it would lie at this position. Okay, it would lie at this position. Else we would have this. Okay, fair enough. So we would just simply return this. So now we would start the main iteration. So we would say int left s is equals to sum of l and r. Okay, we would pass on the prefix sum and we would say l is equals to 0 and r is equals to I minus 1, and we would say write sum is equals to sum of l and r, and then we would have p, and then we would have I plus 1. Okay, and till the value of n minus 1. Here we would also add the condition if r is greater than 0 as well as r is less than n itself. R is less than p dot size, because it might be a scenario that we are requesting till this point. So we don't want this point. Okay. So now this should give me the sum. So I would say if left sum is equals to the value of right sum, then we would return I plus 1. Why? Because the arrays or vectors are 0 indexed, but here it is 1 indexed. At this point it is said. Okay. At this point, if we were not able to return an index, we would return minus 1, that the answer does not exist. Now let me just compile and then see how many errors am I making. Okay, seems correct. So let me just see again. For int I is equals to 0. Yep. R is greater than equal to 0 and R is less than equal to p dot size. We would have the sum of R. Yep, I think I can submit this. Okay. So this is now correct. So that I'm just checking if R is within the range or not, and L is also within the range or not. Okay. So now I would quickly share the tab itself. Yep. First tell me if this thing is clear or not. Then I would quickly go move forward. Can you repeat the point about array with 10 to the power 5 size? So many a times I have seen that arrays of size more than 10 to the power 5 behaves abruptly, so it's better that we use vectors. Now we have a thing known as, so now here we are using the prefix sum of big O of n. So space complexity is big O of n, but the time complexity is big O of n whole c. But here the intended space complexity is big O of 1. So now what we can do is we can use a simple trick to solve this. The simple trick would be that we use something known as running sum. Okay, so I would just introduce you to a new thing, that is running sum. 1, 3, 5, 2, 2. So first we would calculate all the sum, which is equals to 1 plus 3, 4, 4 plus 5, 9, 9 plus 4, 13 itself. Okay. So now we would also have, this is the sum of the left part. So I would simply say left is equals to 13 and right is equals to 0. Okay, we would start from this point. So whenever I hit an index, I would first subtract its value from the left. So 13 minus 1 would make it 12. Okay, and then I would see 12 is equals to 0. No, it is not. Then I would move forward and I would add up this 1 to the right hand side. So 0 plus 1 is equals to 1. Then I would subtract 3, that is 9. So is 1 equal to 9? No, it is not. Okay. Then I would add up. Okay. I would add up this 3 to this point. That is 1 plus 3, that is 4. And then I would again subtract 5 current index from the left. So that is equal to 4. At this point, left sum is equals to the right sum. Okay. And then let us move forward and let us see. So first we are subtracting the current index from the left. That is remaining part is 2. And then we are checking it. After that, we are adding that value to this point. So now if you see the right hand side, 4 plus 2 is equals to 6. Yep. So now this is how we would see. So let us see the iteration. So now what we can do is we would simply make this go like this, and then let us do like this. Okay. First we would have the sum, whole sum into the left part, into the right part. So now we would say int long left, long left is equals to 0 comma right is equals to 0. Why like this? Because 10 to the power 8 and to 10 to the power 16 is more than 10 to the power 9. That is why we are using long. See a reason for this also. So now first we would have the sum for int I is equals to 0 I plus plus, and then we would be saying right plus equals to a of I itself. Okay, fair enough, it's done. Now we would have this for int I is equals to 0, I is less than n, and I plus plus. Now first we would subtract the sum from the right. So right minus is equals to a of I. After this, the sum of the left as well as the right is there. So I would say for int left is equals to right. If left is equals to right, we would return I plus 1. If this is not the condition, then only we would come to this part, and then we would need to add that value. So int left plus equals to a of I. Okay. Now at this point we would return minus 1. Now let me just see, doing this after a very long time. Yup, we are getting the correct answer. Let me try to submit and see how many errors am I getting. Yup, it is solved now. So now the space complexity is big O of 2, because we are using two variables, and ignoring the constants, it is big O of 1. So just make it a habit of understanding that in spite, like, variables would never contribute to your time complexity. Just make it a habit. Even if you define 100 variables, it won't affect. Even if you define 500 variables, it won't affect in your space complexity. So now am I clear with this approach? So this is known as running sum. So as we move forward, the sum gets increased or decreased. This is known as the running sum. Give me a quick yes or no if this thing is clear. Please change this time if it is possible. Actually, now the mentors are working. Okay. Like Abhinav is in LinkedIn, Yash is also working, and I'm also working. So taking POD at 12 o'clock in the night with this much lighting and all affects our sleep pattern a lot. Like we get sleep at around 3 or 4, then we need to wake up at around 8 again. And we can't have our sleep in the afternoon. That is why a little bit of problem is faced when we solve a POD for at 12 in the night. So can I have a quick yes or no if this thing is clear? Give me a quick one if this thing is clear. I would wait for the next 30 seconds, or mention me the line number at which you are not able to understand. Okay, hi, thanks Rashid. So can I have a quick like over the video? Line number 43. I need to repeat. Okay. So don't worry about that. I would explain. I won't just repeat. I would explain the whole thing again. So now suppose we have an array of 1, 3, 1, 4. So the sum of left is equal to 4 plus 1, that is 5, 5 plus 4, that is 9. And then we have the right hand side, which is equals to 0. Okay. We are at this index. So first we would subtract this one to 8. 9 minus 1, that is 8. And in the next iteration, this one would contribute to the right hand side. So we would add up this value. That is why after moving forward, we are adding up this value. Okay. Then we again subtract 8 minus 3, that is equal to 5. And now if you see, 4 plus 1 equals to 5, and this side is equals to 1. Okay. Now if we move forward, we would add up this value, 1 plus 3, that is equal to 4. Okay. Now we have the sum of this part and the sum of this part. Okay, this is why we are adding up the current index. Am I clear to you, Joy Patil? Just give me a quick yes or no. Let me just see in the chat because many a times it happens. Am I clear to you, Joy Patil? Okay, thanks a lot. So any more issues I have, I would wait for the next 30 seconds and then I would turn off this session. Most welcome. Most welcome, Joy Patil. Most welcome, Viva. So I think I'm clear till this point. So if you were here till this point of the video, consider liking the video and commenting on the video so that this reach of this video could be increased and this work could be justified and it would help us to motivate so that we can just keep up this good work. That's it for today. This is me Siddharth Hazra signing off. Thank you everyone.